Hello, in this section of the tutorial we're going to begin to learn how to use our calculator to do some more statistical analysis. And so specifically in this section what we're going to first begin to learn how to do is use the calculator to create a histogram and also what we call a box plot, and we'll talk about that a little bit later. A histogram is really easy to understand concept-wise. Basically what you're usually going to have in statistics is you're usually going to have a bunch of raw data. Like maybe you did a telephone survey where you asked questions on the phone, or maybe you did some survey, some polling center or something like that, and you had a questionnaire or something, and you just got a ton of data that describes your sample. And so, statistics lets us really look at that data in different ways. And so a histogram is one of the most basic and fundamental and useful ways to look at raw data. So in order to input data, which is usually what you're going to do when you have a statistical problem, you need to be able to input it into a list. So you'll just have a whole table full of information that you want to basically plot and look at. So what you need to do is go into the stat menu here. Here's where you input your data. And so the very first thing here is really what you want to do. You want to edit your data. You want to edit your statistical data. Now these other things down here, it lets you clear the list and sort ascending and sort descending if you have data that you put in there and then you'd like to reorder the data once you have it in there. But just to input the data, you want to go into the edit menu here. So hit enter and you will be presented with this guy. Now notice that I actually already have some data in here. I just had this left over from something I was doing earlier. So we want to clear that. The easiest way to clear the data that's in a list, which is what's going to happen anytime you use these functions, you're going to come back here and you're going to see these lists full, is just go up to the title here and hit the clear button. And you'll see that it tells you have an equal sign there, and you can just hit enter and then the whole list will be cleared. So if you've never used these functions before, your table will be blank like this, and if you have used them before, then they'll be populated with information that you'll need to clear out. Now notice, we go up to the headings up here, we have 6 lists in this calculator. And that's it. So we go back to the beginning here. So we have L1, L2, L3, L4, L5, and L6. And these are different lists. So literally, you will go in here and type in your values for your data. Let's say maybe you're doing a measurement, maybe you're a teacher or something, and you're taking a measurement of all of the heights of your students in your classroom. As far as their height, from the ground. And, you're obviously going to get a lot of data. You're going to get a lot of different heights there. And you would like to look at this data statistically and just sort of see what the distribution is in your class. Do you have a lot of tall kids? Do you have a lot of short kids? Do you have just a bunch of people that are all clumped at one height, or are they all spread out? A histogram is a really great way to really be able to look at that. So let's say we have, 20 people in our class or something, and we'll just go ahead and input some data. So let's see, kid number 1 is 60 inches high. And forgive me for working in inches, but I think it's just a little bit easier when talking about height. This could easily be centimeters or the height of anything. I mean, it doesn't really matter what the unit is, but let's say this is 60 inches. This is one kid. Let's say the next guy you look at, he's 55. Next guy you look at is 47. And then after that, next guy is also 47. Next guy after that's also 47. You have somebody up at 62, another guy at 62. Another guy at 63, some tall kids here, and then because 5 feet high would be 60. Let's say you have a real outlier here at 77, right? And let's say you have another guy at 59, another person at 59. Let's say you have a real short person, 47. In your class. So here we're up to the 13th student here. And so what we have here, it's telling you here, this is list 1 and this is the 13th entry. That's what parentheses mean. So we're going to go up to 20 because we have 20 people in our classroom. Let's say we have another child at 49 inches. The next guy after that's 49. We have a couple of girls, 61. Then we have somebody else, 62. Somebody else, 63. And then last 2 people, let's call them 59 and let's call them 58. So we've entered 20 different people in here. And we haven't really done anything other than have them come to the front of the room, we measure them, and we type them in. That's all we did. So we have all of our data here. We've collected it. We've taken our survey or our poll or whatever, and we've put it in here. And it's basically really hard to visualize what this is going to look like. Yeah, we have the numbers here, but we like to look at things in terms of graphs. It really can help you visualize things. So we want to do a plot of this, but we don't want to do a regular plot, which would be something like this. See, I'm still in polar mode from earlier. It's not something that you can give an equation and plot an equation. You're sort of plotting raw data, and you want to look at the relationship. So you don't want to go to y equals because you don't have a function like this. You want to go to a statistical plot. So you want to hit second function and then hit this guy. And then you have your statistical plots up here. So you're allowed to have 3 statistical plots plotted at any one time. So you can have 3 different lists of data plotted in different ways all at the same time. But I'm going to tell you right now that on this calculator, if you start plotting more than one of these at once, it's going to be difficult to really look at it. It's the facts of life here is that it's a black and white calculator screen, and the resolution isn't really great compared to like a computer. So it's useful in a pinch, but it's not like you're going to have 3 complicated statistical plots on top of each other, because it'll just be really hard to figure things out. So my advice is to keep it simple and keep it one at a time so that you'll know what you're doing. So what you want to do is it's asking you, okay, do you want to edit plot number 1, number 2, number 3? So if I did have 3, I could go put and link all the lists in for all 3 of these guys, and then I could look at them all at once. But now I'm just going to do one at a time. Notice that it says plot 1 off, plot 2 off, plot 3 off. So that's because up until now, I haven't been doing any statistical plots at all. So most of the time they will be off. But we're going to change that. So go into number 1. You can hit enter for plot number 1. And it's telling you this is plot number 1 that we have highlighted here. And then right now plot number 1 is off. So we want to change that to on. So we're going to hit enter. And the next thing is it's asking us what type of plot do you want. So here we're going to select the type of plot that we want. And there's a bunch of different ones here, and we'll talk about them a little bit later. But basically you want to select the one that's blinking now. You do that with the enter key here, and it's the one that looks like a bar graph. And that is the icon for a histogram, which is what we're learning how to do here. So that's that. Then you would go down here. The list that you want to pick right now is L1. And that's the list that we've already filled out our data for. If you had a bunch of lists in memory, then you would just hit enter here and select a different list. But there's no real need to do it like that because we are just fine with the first list that we have. And you can see the different lists are down here. So if you wanted to change it to L2, you would go here, etc. But let's go ahead and change it back to L1. So you have L1, 2, 3, 4, 5, and 6 there. So we have L1 there. Frequency, really just leave it alone. For what we're doing here, just leave it alone. You don't have to mess with that. All right, so we've got the plot on. We've selected histogram. We've told it the list that we're linking to. That's what we're going to plot. Now, if you go over to the graph menu, which is your first thought to graph this thing, and you press that, you're not going to see anything like what you think you would see. You see something like this, and you're like, whoa, what's this? Let me zoom out. Let me see what I have here. Or let me go to Z standard, see what it is. And it is a leftover plot from earlier. It's kind of hard to see here, but this is a plot of these polar equations that I already had there. So rule number 1 is when you have statistical plots, see how plot 1 is highlighted right now? That's because I've enabled statistical plot number 1. But first thing you want to do is just a good habit. When you're doing this stat plot stuff, turn off your other graphs so that they don't show up. Now, if you go back to the graph menu, those have disappeared, but you still don't see your statistical plot anywhere. So you're thinking, what happened? What did I do wrong? Well, for whatever reason, and I don't particularly think that this is a very great way to lay out the calculator, the way that you plot statistical plots is not to press this graph button. That's your first indication or inkling, but you don't do that. You go to the zoom menu of all places, and you go down and scroll down past number 7, and you'll see zoom stat number 9. So basically, once you get the list in there, once you enable it, once you tell it what you want to do, then you have to go and press number 9 inside of the zoom menu, and then you will start to see your histogram. You'll start to see your histogram. So this is a basic histogram here, but in general, the initial values for what the calculator chooses to draw this thing, in my opinion, is usually not very good. So what we want to do is go into the window menu here, and we want to choose, don't look at the theta stuff here, that has nothing to do with any of this stuff, but for statistical purposes, the x-min and x-max is going to be on your axis here, what your min and max is for your x-axis. That's probably okay, because remember, our heights generally was from the 40s on up into the 80s like this. But what we want to do is let's pick a little bit of a better value here. Instead of 47, let's pick, and you have a lot of latitude here to do what you want to do, but let's pick 40, and let's go up to 90. So we'll pick nice round values. That's always a good thing to do. And this X scale here, this is basically going to define your what they call the bin size for histogram. It's better just to show you by example. So let me go ahead and pick, for now, let me go ahead and pick 5 as the bin size. Let's see if that changes anything. We'll go back to the zoom menu and hit number 9, which, if you forget, that's zoom stat there. And of course, you can just make the mistake that I just made, which is go back to zoom stat. That's not going to do anything because it changes everything back to the default. So let's go back to 40 here, and then we'll go up to 90 here. And I changed my mind a little bit. I want to change this to 2. And now you go back to the graph menu. And so you see your histogram here, and it's looking pretty good. So you've got these bars, and basically what's happening here is these bars are representing the relative frequency, or the more times that a certain height occurs. So the best way to figure this out and look at it is to click your trace button. That's probably the best thing to do. And so let's go ahead and hit trace. Now what it's telling you here is my bin size that I picked, let me go back to the window menu, don't forget, was 2. So that means that the width of each of these little rectangles is 2. So when I hit trace, what it's basically telling me, see it's blinking over here? It's telling me that between 40 and 42 inches, I had 0 people. N is equal to 0. That's the number of occurrences. Between 40 and 42 inches, I had 0 people. Now I trace over to the right. Between 42 and 44 inches, I also had 0 people. Between 44 and 46 inches, I had 0 people. Now, once I get between 46 and 48, I had 4 people in that range. So that's what we call the bin range. See, the width is 2 of that, and that's adjustable, and we'll go adjust it in a second. Now, moving along, between 48 and 50 people, I had 2 people. Now, between 50 and 52, I had 0. But between 52 and 54, I had 0. But between 54 and 56, I had 1 person. So I think you get the point here. You can scroll through here and see at a glance, okay, between 62 and 64 inches, I had 5 people. Now look at this person way out here, or these people way out here, way up high over here. There was 1 person between 76 and 78 inches, and I think I told you, even as I was typing in the material, the raw data, that there was 1 outlier. This is what you would call an outlier. Most of your data is certainly over here. You can tell from the height of the rectangles that your class, most of the people are somewhere around this height. There is some distribution of people down here that's a little bit shorter, and there's 1 guy or girl really far out here by himself. That's called a statistical outlier. It's part of the class, but there's always that 1 kid in class that's super tall or super short. You can have an outlier in the other direction. Now let's go back to the window menu, and let me change one more thing. Let's go and let's change this guy, this X scale, to 5 instead of that. We're not changing anything else. We're just changing this to 5. We go back to the graph menu, and our histogram has changed quite a bit, because what we've told it is we don't want these rectangles to have a width of 2 inches. We want them to have a width of 5 inches. So to understand that, it's better to hit the trace button again. So now look at what it's telling us. Between 40 and 45 inches, I had 0 kids. When I go over here between 45 and 50, notice it's a wider range now. But between this wider range, I had 6 kids. The reason it's more people is not because anything's changed. It's just that I'm widening the bucket, or what they call the bin in statistics. And so that's why the graph looks different. It's representing exactly the same data. It just looks different. Just much like you can zoom into a function and make it look a little different. It's the same function. When I go over here between 50 and 55, I had 0 people. When I go over here between 55 and 60, I had 5 people. and then I had a large number of people, 8 people between 60 and 65. And then when I go out over here, again, the single outlier, 1 person between 75 and 80. So that's basically how you construct a histogram, and that's what they're useful for. You can type in a bunch of information, and then you can just go in there and link it in there and plot it and play around with the bin size, and you can see what it looks like. Is it a bell curve? I mean, you could sort of say it's almost like a little curve, but this is kind of destroying that idea a little bit there. But I think you could definitely say that most of your kids are somewhere around the middle. There's another little population of people that are a little bit shorter. This guy out here is really what we call an outlier. He's part of the data set, but is not representative of like an average person at all. And that's a really great introduction to plotting histograms. All right, now we want to go and also learn about a box plot, what's called a box plot in statistics. So instead of representing this as a histogram, which personally I think is very, very clear, we also learn about box plots, or box and whisker plots, sometimes you hear them called. So let's go second function, stat plot again. And I'm going to go in here, and I'm not going to do anything other than edit what I've already done for plot number 1. But instead of histogram, I'm going to come down here and select this guy. This is the icon for a box plot. Now, there's 2 icons that look really similar. The only difference between the two, let me stop it from blinking so you can see. The only difference between the two, notice that this guy has a box plot, and this guy has a little rectangle looking thing as well. The only difference is there's 2 little dots out here off to the side, and this guy does not have those dots. Other than those little dots off to the side, these 2 things are exactly the same thing. These little dots basically mean that when I use this function, I'm going to plot the box plot here, and I'm also going to plot any statistical outliers. And these little statistical outliers are going to be represented by little dots out there. And then over here, these guys are not going to be, no outliers are going to be representative there. They're just not going to be plotted. So let's go and select this. And we're going to have the same list. L1 is the same data. You could change it if you want to. Frequency 1, we're just going to leave that alone. The mark here, this is representing what your outlier is going to look like. What are these little dots going to be? Are they going to be little crosses, little dots, or little rectangles? Well, let's just leave it alone. It's fine the way it is. We've got the plot on. We've got it as a box plot with outliers. We've got the list there, and we know what our little icon is going to look like if we have any outliers. Okay, so we're done. Now we go over here and just see what we have. We go to the zoom menu, and then we go to zoom stat and see what we have. And what we're going to have is our box plot, and it's right there in front of us. And so what you can do is hit trace and learn a little bit about this population. So what it's telling you here as you scroll through this guy is it's telling you some interesting facts about your distribution is really what it is. You can tell at a glance that most of the people in your class is falling between this range right here. So the first little blinking thing is telling you the lowest value of the data that you had was 47 inches. That's the lowest person out here, and that's why it extends off to the left. Let me skip through this middle part here. Way over here, the maximum person you had was 77 inches. That was the highest guy way out over here. But based on the weight of the distribution, if you remember from our histogram, most of the people were kind of over here, and then there was the one person out over there. That's why the rectangle is mostly down over here, because it's trying to tell you, look, most of your people are here. There's some people down here, and there's one guy out here, but most of your population is in this range of heights over here. So that's what this is telling you. This is your minimum value of height. This guy right here, this is what we call the first quartile. Basically, it's the first 25% of your population is what that means, and it's right here. This is where roughly the median here, the 50% mark of your population. And then this guy right here is what we call the third quartile, which is, basically your 75th percentile right here. So we say by definition that most of your population is going to fall between the 25th percentile, the first quartile, and the 75th percentile, which is the third quartile. So most of your people are falling between these two heights, between 62 and between 49. And in the middle here, the median is 59. So that's telling you at a glance that this is where most of your people are, this is where the low people are, and this is where the high people are. So notice in this case that we have a minimum value over here of our population. We have the maximum, which was over here at, I believe it was 77, right? Which we kept saying that was an outlier, but it's not represented as an outlier in our plot, and that's just because the calculator has some internal cutoffs to what it believes an outlier really is. So this was right on the edge where it barely captured it as part of your distribution, and it didn't consider it an outlier. But we can test this and play around with it a little bit more by going back to our list. This is the data that we had. We'll go back to the bottom of the list. So you see this is our 20th entry right here. Let's add another entry and let's put it at 100. So we're going to pick a height that's just crazy impossible. So we'll put a height of 100 there. That is a true outlier, really far away from everybody else. We'll go back to the zoom menu, and then we will go back. Well, if we go back to our graph, what's going to happen is it's going to have the same zoom, so we don't really see anything. But if we go to zoom again and go to zoom stat number 9, then it's going to zoom out, and here's our outlier out here. So when we hit trace over here, we'll see the minimum was 47. First quartile has, everything's changed a little bit because now I have an outlier out here. There's 49, median's 59, third quartile 62. So most of our population is falling between the first and third quartiles. Here's sort of the maximum of what we are considering our base population, and out here is basically an outlier. It's calling it max X, but any dots that you see out here way far away from everything else is what we consider an outlier. Typically in real life, outliers are, I don't want to say they're ignored or deleted, but when you have outliers, you typically think that those are, 1 in a million sort of things, and you don't. If you're looking and trying to understand the population of something, you recognize the outliers, but you don't lean on them really too much because, in every experiment, there's always going to be a case or something where you might have something way out beyond your normal data. So that is basically in the TI-84 a good introduction to how you create histograms and how you create these box plots, or they're also called box and whisker plots. And so for basically what you need to do for any of these is go into your list editor. You can hit edit to edit the list. You can also sort the list and clear the list with these guys down here. But you go in, you edit your list, you type in your data. You can add up to 6 lists, and then once you do that, you go into stat plot up here. You turn the list on by going in here and turning it on. You select the type of graph you're trying to create. You link it to the list of data you have. And notice if we had selected this guy down here, let me go over here. Instead of the guy with the outliers, which is what we picked, if we had selected the other guy, then there's no option at all for outlier tick marks because it's not going to present them to you. So you have the option of picking those two guys. Once you do that, in order to plot it, you have to go to the zoom menu, and then you have to hit zoom stat. And even after you do that, it's likely that you're going to have to play around with this stuff over here to get it to look exactly like you want. I'm not going to lie to you and tell you that you're going to be in your calculator doing statistical analysis a lot. Nowadays, with computers being so cheap, you can just go and do colorful plots on any computer and really understand the data a little bit better. But on a test or on an SAT, you're not going to have a computer. You're going to have this. And so knowing how to use it is going to save time for you. And if you can just get one more question correct because you understand this and know how to do it, then that's going to be worth your time.